Hey, hi everyone. Good day. Hi Shivam. Hopefully you can hear me clear. We
Hey,
have
hi Mamta. Yes, I can hear you.
we have good amount of people joining in. We have still around a minute or two in hand, so we can start with the introduction. So people, those who are already logged in, can you introduce yourself in the chat? Tell us what has driven you into this webinar. Tell us what's so exciting. Did the topic look exciting, or do you think machine learning is the new future? That's the reason you people are trying to learn or uh, like grab new technologies or something like that. So please introduce yourself. Yeah, Shivam, please have a look. I think you should have the option now available. Shubhangi says so many days too, listening to you. Hi Shubhangi, how you doing? Yeah, Shivam, we have your screen visible.
Okay.
Okay. So hey Arvind, in GCP, what exactly you do? You work on data science, or you work as an administrator? Anirban is saying that he's already working as a machine learning engineer, which is awesome. Azure ML platform is shaping us. Okay, good. Great that you people are already working on latest technologies. It's really nice to see. Thanks, Venkat, that you find our sessions useful to join in and learn some new stuffs. Now, Shivam, you have your participant Ranjit, who has cleared 303 and he's thanking you for the session.
Hey, hi Ranjit. How are you? Congratulations.
So a lot of people are introducing. Just tell us which part of the globe you people belong to. Maybe you are from India, you are from, like Fidan says, I'm from Turkey. I'm an electrical engineer, which sounds really nice. A student. Hi, Siddharth. TensorFlow is one of my core skills. Nice to know that, Arvind. So Shivam, maybe you can just tell us what would be the prerequisites of taking DP-100 meanwhile when people are joining it, so that people at least know that what prerequisites they should have before they should really start to think that they should get certified on DP-100. Like if you see Akash is saying that he would love to get certified on DP-100. So if we can specify the prerequisite, that would be helpful for them.
Definitely. So, the certification is for data scientist on Azure platform, and this certification aligns machine learning with cloud. And as the prerequisite, we need to know the basics of machine learning and little basics of Python, and rest of the things if you come to any training as such with these prerequisites, the rest of the skills you can pick up on the way. However, and you also have to know basics of Azure platform itself, little bit of know and how of how cloud works, what is object storage, what is data lake, little basics around that. So little bit of cloud knowledge, programming background, maybe a little bit of Python background will be amazing, or R,
Okay.
and machine learning.
So Shivam,
Some know-how of
if
that.
you think that I am a very new person to Azure and I don't know how to run through the Azure portal, click where to spin up few of the services. So do you think when we join into DP-100 classes like this, does it give us a fair amount of idea to run through the portal and pick up little bit basics of Azure so that we can work with DP-100 exercises?
Yeah, definitely. So what do we do as we, in the way we organize the trainings or the way we organize this course is that we give prerequisite at least 1 month ahead of the start date of the training. And apart from that, we give the Azure fundamentals, like you can brush up your skills in Azure fundamentals, know about, we give the subscription as well. The participants can go in and create resources for them, spin up machines as such. And definitely during the training itself, we have so much of hands-on. You can say approximately 55% of the training is hands-on itself. So the balance is very nice. So if somebody is even new to the subject, but they are willing to learn, definitely they can pick up the cloud as well as the machine learning concepts.
Okay, sure. So Shivam, we have good amount of participant already joined in. Kupal, let's start with the introduction and then maybe Shivam can pick up and present the topic.
Sure, Mamta, thank you so much. Hello everyone, welcome to today's webinar. So just to give you a quick brief introduction about Shivam Sharma. Shivam is an author, cloud architect, speaker and co-founder at Tech Scalable. He is passionate about ever-evolving technology. He works on Azure, GCP, machine learning, blockchain. He architects solutions on cloud as well as on-premises using array of platform technologies. So just to give you on today he will be presenting a webinar, or I would say rather he'll be talking about how to train machine learning models at scale. So over to you, Shivam.
Thank you, Kopal. And let me quickly start the camera itself. Hey, hi everyone, how are you? So hopefully you can see me as well. Now, maybe good morning, good afternoon, good evening to you from wherever you are joining in. Thanks for being over here. And do let us know in the chat window if you can hear me clearly. If there is any problem with the background noise or any other issue, just inform us. Now we will be talking about, if I walk you through the agenda for the day, we will be talking about machine learning on the cloud platform. That's the first, the why machine learning on cloud. That's one thing which we want to understand. Then we want to understand the architecture and the concepts of Azure machine learning. Like what is so special about Azure machine learning? Is it providing us with any special capabilities or integration so we can do maybe machine learning on, let's say, DevOps with machine learning, or how can we distribute the training and train the models on GPU and CPU? What type of options is it providing us? So these type of things we will be checking in the session itself. Now this training is, or this session is for someone who wants to certify in DP-100, or if you want to learn the cloud platform plus data science, or data science plus the cloud platform in one go, that is something for you. Now, if I walk you through that, we'll be talking about the no-code modeling designer. How do we design solution without using any Python or R or any other programming language as such? What's the option? How do we do it? We'll go through that. We'll see the machine learning with TensorFlow at scale. We'll also talk about distributed training. So I have the agenda a little expanded over here. So check this out. So we'll talk about the compute instances, compute clusters, data set, data store, inference cluster, attached compute. These are components of, you can say, the cloud machine learning solution. And we'll understand what's the meaning of them, why do we use them, where do we need them, and so on and so forth. Apart from this, we will also talk about the like when we do distributed training, right? So a lot of concepts comes into play. Model, you can parallelize the model, you can have parallelism in the data itself, and you can have parameter servers, synchronous, asynchronous parameter servers, all reduce, ring, all reduce. So you might have heard these names, or maybe if not, then I'll help you with that part. We'll understand the concepts like what do we need to know to be able to distribute my model and do the ML on scale. We will also talk about how do we containerize the solution, what does Azure offers, and where do we deploy these, right? How do you operationalize the model? Where do you deploy it? What's the final destination where you have to push your trained model in production? We'll cover these type of things. So let's get started. And in the starting, we have the basics of AI as well, and we'll have you can say we'll build up to the advanced topics. So we'll start from here. And just give me 1 second. Let me quickly move the camera around. Okay, so check this out. So what is machine learning? What is artificial intelligence? We'll start from here. And the very first thing which comes to mind is that those systems, those software or the machines which imitate human capabilities are called artificially intelligent. They are smart. They can recognize any behavior, any abnormal behavior based on events. They can make decisions based on data and past experiences. So these type of systems can understand the visual input. They understand written, spoken language. They can engage in dialogues and conversations as such. So these type of systems are called as artificially intelligent system. Now, why is cloud coming in the picture, or where is the cloud coming in the picture? Now, cloud platforms, they provide storage locations for data science, machine learning, AI. The very fundamental thing which we require is the data. And at times the data is it might be structured, semi-structured, unstructured. So if you have structured data, you want relational databases. If it is semi-structured data, you want some sort of graph DB, key value pair, or any location to keep that, maybe any MongoDB or column family databases. If it is unstructured data, you may go for data lakes, you may go for object storage. So these various type of storage locations are available in the cloud platforms. Doing the same thing on-premise is technically possible. However, it takes more time to deploy those solutions. Secondly, you can scale out whenever you want. You can scale up if you want. And if you don't want the resources, you are not stuck with the hardware. There is no capital expenditure. You can simply reduce the instances. You can scale in or scale down. And whenever and you pay for only what you use. And we have you can say very powerful machines which have GPUs or TPUs in them for the machine learning or for training the models. Now in Azure, there are multiple families of solution which Microsoft provides. We have Azure Machine Learning Service. So there is one flagship solution from Microsoft called as Azure Machine Learning Service, and that solution is something which we will be covering today mostly. And apart from that, we also have cognitive services in Microsoft Azure. Cognitive services are for developers. These are API endpoints, and the models are pre-trained, pre-built models are there. And you don't have to train these models yourself. You just have to use them. So for any horizontal product or any horizontal requirement, definitely cognitive services can be used. For creation of chatbots, we have bot services in Azure. So you can create conversational bots. The conversational bots can have speech input, they can have text input, they can have image input. So they can you can have to and fro messages with them. You can say host them in the cloud itself. So there is a lot of solutions which Azure provides. So before we go into the depth of the agenda today, before we go into the major topics as such, we'll understand where have we seen AI being popular these days. You all will be able to understand these locations. You all know, or you might have heard about computer vision. So computer vision is when the computers, whenever we have the algorithms or the machines, and the input is in some sort of camera or video input or picture is there, which acts like the input, and we have to do some analysis on top of it. So computer vision is one field where machine learning or AI has you can say increased or done innovations in leaps and bounds. Apart from this, when we talk about computer vision, we have a lot of more applications over there. Classifying the images, this versus that, cats versus dogs, face differences between the faces itself. How do you log into your cell phone? It's face detection and then face classification as well. So we also have object detection as one of the application of computer vision. This is where in these fields, AI deep learning is playing a major role these days. Semantic segmentation of image, like pixel by pixel, finding the difference between the background and the object over there. Image analysis, what is going inside the image? What is this image telling us about? A person is walking with a dog on a street. So the analysis, the summary of the image, summary of the entire the scene over there. Face detection recognition, and definitely it also helps in OCR, optical character recognition. So these are some of the fields where computer vision is very popular. You also have translation. So deep learning, machine learning, AI has played a huge role in translation as such. Text to speech, speech to text, speech to speech in real time, converting one language into another. So I'm speaking in some one language and you will hear in another language. So those type of real-time conversions, they are part of translations. So we have talked about, so these are all the fields, and there are many more fields apart from this where AI is playing the innovation, is doing the innovation as such, and we are finding new job profiles, new job roles. We are finding new ways in which development can be done. Now, at the core of AI is machine learning. So, or the heavy lifting thing is machine learning. So what is machine learning basically? Now, if I simplify the topic as such, I don't want to do death by slide. We'll go in the demos very soon. However, still for those who are yet starting their journey on ML, let's understand what is machine learning. Now, machine learning is about finding the patterns from the data. Now we will be having algorithms over there. These algorithms, they will find the patterns, any type of correlation in the data, any type of maybe you have last historical data from stock market. You want to find some stock prices from tomorrow. So based on the learning which the model has done, it will store those learning in terms of weights, and then the predictions will be done on top of it. So at the core, we have machine learning, the heavy lifter. Now, from the certifications point of view, and from the practicality of the subject, we have to go into like what happens at the back end. Like when we talk about machine learning, it's very one of the core fundamental thing over there is like, how do you select the algorithms? Which algorithm am I going to select? Will it be some sort of supervised learning? Will it be unsupervised learning? Whether it will be semi-supervised learning? Am I going for reinforcement learning? Or is this solution good for doing classical machine learning on top of it? Or is the solution good for doing deep learning on top of it? So what is my requirement? That's the very first thing from where we start. Like, what do you want to do with your data? Apart from that, we also have accuracy. Apart from that, we also have training. Is the data linear in nature or not? Is the relationship linear in nature or not? How many number of parameters are there which you are training? How many columns are there in your data set? So we call them features as such. So how many features are there in your data set? How big is your data set? So to understand the requirement better, there is one cheat sheet which I'm sharing over here. So whenever we have to think about selection of the algorithms, which is one of the important part of making the correct models, we start from here, from the middle itself. Like, what do you want to do? So the very first thing is like, what do you want to do with the data? So do you want to generate some recommendation on top of it? Are you looking for any, let's say, item recommendation, or you're looking for user recommendation system, or you're looking for some sort of, okay, I have seen this I have purchased this product, which other product should be recommended to me? If you're looking for that, we have the recommendation solutions in Microsoft Azure machine learning available, like SVD is there. If you're looking for discovering of any structure in the data. Any hidden structure is there in the data, you want to figure that out. Then we go for clustering family of algorithms over there. If you want to find any anomaly in the data, let's say you want to find the frauds in the data, fraud detection or anomaly detection is there, then we have anomaly detection as the field where we have algorithms we have to select from. When we predict the values, if you want to find some values in future, then regression is the family of algorithm which we go for. And as part of regression, there will be many more algorithms. I don't have everything in the screen right now, but then we select that, okay, do we want fast training? Is the data set smaller? Do we want the model to be more accurate as such? For text analytics, we have full family of solution available. For when you predict between various categories, like you have 2-class or multi-class classification, cats versus dogs or cats versus dogs and something else, right? So we have 2-class, multi-class, and then there's multiple algorithms as part of it. So the problem statement starts from what is your problem statement, or what do you want to do with your data? What are you trying to solve? What are you trying to achieve? How is cloud helping us out over here? What is Azure doing as such? How can we do all this in Azure platform? So I'll take you to my Azure portal now, and we will talk about Azure machine learning. Like, what does it provide? The scalability, on-demand storage capabilities, the workflow orchestration, model registration, the matrices over there, the model deployment as such. So I'll just quickly take you to my Azure portal over here. Now I want to start my journey. I want to create this Azure machine learning service, and I want to start with that. So the very first thing is like, you create the resource. So I'll just click on create a resource, and over here I'm saying machine learning, like this. That's the first option, create machine learning. So I'll be selecting, let's say I have this webinar going on. Let's say I'll say this is webinar. We'll put 1 over there. Let's put it like this, and text scalable. Let's say DP-100 demo. So that's my machine learning workspace where I'll be doing lots and lots of activity. So apart from that, there's some other things are getting created. I'll explain that, right? Storage accounts, key vaults. For now, I'm just clicking on it. So basically what I want to do is, by the time I explain all the details, I want the resources to be deployed over there. And I'm just clicking on save over here. And I'm just waiting for Azure to show me the tick mark. And okay, great. Okay, so what have we done? Let's understand that in a whiteboard, and then we will come back and we'll do something with this machine learning workspace. So check this out. So basically, whenever you have to start your journey with ML in cloud in Azure, basically you have to learn some basic concepts over there. So we have concepts such as data stores are there. So let's say data store, right? We have concept which is called as data set, right? So what is data store? If we start from there, data stores are like we were talking about that, right? Like structured locations where I will keep my structured data. So this is SQL in cloud, Azure SQL maybe, and relational database where you have it over there. Maybe I have object storage with me. Object storage is Azure storage account. It's a very good location, a very cheap location for storing your unstructured data, images, small files as such. We get a very good redundancy and throughput when we read from storage account. So this is storage account. So as a data scientist, your data might be lying in the object storage over there. So what do we keep over here? This is relational data, right? We keep unstructured data over here, like that. Very good location for keeping unstructured data. Then you might be having more locations. You must have heard about a word called as data lakes. Data is so important. We don't throw data anymore. We want to keep the data with us. So Azure offer one solution called as Azure Data Lake ADLS, like that, Azure Data Lake Storage Solution. So for example, I can keep some X amount of data over here. There is no limit on the data which I can store in Data Lake. It's unlimited. There is no limit over there. So my data might be lying in the data lake, and then I'm responsible for pulling it from there. So data stores part of Azure are the locations where data really exist. Like in the data store, you will have the data lying over there, either structured, semi-structured, unstructured, but data will be somewhere in data stores over there. Now, from these data store, whenever you have to pull the data, so let's say this is my compute cluster. I have my compute cluster over there. So compute cluster is the location where the model training will happen, where you will do the machine learning, where you will see the distributed machine learning happening, where you will make sure that multiple GPU machines are there, or you're going for maybe multiple CPU machines as such, like this. So this is my compute cluster, like that. They have maybe single GPU or maybe multiple GPUs per machine, like that. So now I will be doing my model training in this compute cluster. So whenever we are working with the compute clusters, or whenever you are doing a deployment, you might be writing your code in Python, or you might be using the GUI to write your code. So maybe I have the GUI over there. I will show you what do I mean by GUI. Or maybe you are having the AutoML, pretty popular, right? AutoML. So you are using AutoML to run your models, but basically the training is happening in the compute cluster. Compute clusters are the one where or locations where the training happens. So now if I have to pull my data from here, imagine I want my data to be coming from that location, and I want the Python code to run on top of it. So as a type of encapsulation, what Microsoft did, they created data sets over here. We have file data sets and we have tabular data sets. So what are these data sets? They are just metadata. They don't really have data over there. They just are just metadata as such, and they contain the connection configuration. What type of file do I have? What's the file format? Is it CSV, TSV? Is the first row as is header, or is it not the header? So all those type of metadata is stored as data set. It makes the life of data scientist easier to create data sets over there. So file data sets are used whenever we have images or we have a lot of files as such. Tabular data sets are used whenever you want any pandas data frame finally to be created. You use that. So if I put the arrow correctly, let's say I am creating some tabular data set, and I'm using this in my code over there. It makes my life easier. It makes my code easier to work and deploy. So let's say this is my data frame. Now it's distributed over there, and I'm running my job as such. Now, whatever I am creating, whichever machine learning model I am creating, that machine learning model, once trained, has to be version controlled. You must have tried, so there's so many models which we try. There's so many, it's always like, okay, if we try that one more thing, maybe we normalize with this, maybe we try one more transformation, maybe we try one more algorithm, maybe we have one more iteration, then definitely it might end up having a higher accuracy or more performance, or maybe it will stop. Maybe we want to stop the overfitting over there. So whatever you want to do, there might be lots and lots of multiple models which are getting created. So what Microsoft provides inbuilt is the model registry over there. So whichever ML model I am training over here, that machine learning model can be registered, and I will have the versioning of the models. So this is my machine learning model 1, and maybe this is machine learning model 1, but this is version 2 of it, right? And I have more machine learning models. Let's say this is ML model 2, maybe any other experiment. Maybe I did regression, maybe I did classification, maybe any type of algorithm I ran. Multiple models are there. So the registry is inbuilt. So this is something which is very unique, which is very useful also. We need the solution that we should be able to have the registry inbuilt over there. Now, when we have to deploy something, like if you really want to deploy the solution in production as such. So containerization is very useful. It makes the models platform independent. So what we can do, there is a concept in Azure called as a model registry, like that. So let's say model registry. And what is this model registry? Basically, the real name of that model registry is called as ACR, container registry, like this. That's the real name of it, container registry. What this container registry does, this container registry basically stores the Docker containers over there. So when we take these models over here and we put them into Docker containers over here, and this is my machine learning model, let's say M1 model. This is version 1 of that M1 model, and I have all the dependencies in this Docker image. All the dependencies are there to require for this to run. Some extra files are also there. So for now, don't worry about them, but I'll just put it over there like score files. Whenever you run things in production, the data will be coming over some maybe some API calls. So you might be needing some extra. You might need some extra bit of codes here and there to be able to pick up the data from the API call, put into an array, and do the prediction and throw the data back. So with all the dependency packaged together, so here we have everything together in one package. We deploy this, right, like that. We deploy. So as part of Azure ML, we also offer, or Microsoft also offer, deployment targets. So deployment targets over there. Now these deployment targets can be of, you might have heard about Kubernetes, right? So you can have Kubernetes in Azure. So Azure Kubernetes services. Azure Kubernetes services. So AKS can be used as a deployment target. I can deploy my solution there. I can auto scale my solution over there. We can also have other solutions like container instances, Azure container instances. So we can deploy these solutions over there. So in a nutshell, basically, this is my Docker container, and now it is running over here. And that's my machine learning model. It is loaded in memory, and now my APIs are exposed and data is coming over API call. And when the data comes over API call, the prediction happens, and whatever output comes, we are throwing the output back. So this happens in production. So what are the components in Azure machine learning which you should be aware of? We have data store. Data stores are the location where really data exists. Data sets is the metadata on top of it. It makes the life easier. It basically encapsulates the data store connection string and the metadata of the data. Compute cluster is the real location where the training happens. Registry is basically the versioning of the models. Once the model is versioned, we can put the models in container registry over there. What is container registry? Container registry is the location where the Docker containers with the models inside that, they are stored. And then we have deployment targets. We deploy them in production. So if I go back to my Azure portal and take you to my machine learning instance. So sorry, this is my machine learning service got created. And I just clicked on the launch option, and that's the look and feel of it. This is called as machine learning service. You see this auto ML designer data set over here. There are a lot of things. I have not covered all the things over there, but compute, data stores, pipelines, models, data sets, designer. So what I'm doing, I'm clicking on compute, and I'll click on compute. This is the compute cluster I was talking about. So this compute cluster is the compute cluster over here where we will be doing the model training. So we'll create one compute cluster. Let's click on new. And what am I looking for? Am I looking for maybe CPU or GPU based machines? So maybe in GPU based machine, what options do I have? I can go for 2-core Tesla K80. Tesla K80 is basically, you can say, the older one. Now we have more options. It's not whitelisted in my account over here, but we have Tesla V100 as well. And you can have multiple n number of GPUs on that. So for now, I'm okay. I'm just going for maybe, let's say I'm going for some 2 cores or maybe 14 GB RAM, or maybe 4 cores and 28 GB RAM, and this is my compute cluster. How many minimum nodes? One of the good things about AML is that the scalability. You can specify how many min max do you want, and the timeout. You don't have to worry about shutting down the cluster. It will automatically scale down whenever the time passes by. So I'm creating let's say 0 minimum node, maximum maybe 2 or maybe 3. Let me put C like that, and let's create this. So in the meantime, this comes up. I'll just go to this compute instance over here. I'll click on new, and I'm okay with CPU. Default size is good enough, and I will create one instance. So let's see if, okay, the name already exists. Let me randomize it. So the instance is coming up over here. So what is this compute instance, this new solution which I just created? So this is your development environment. Now in enterprises, we are not allowed to keep the code in our laptop itself. You will be using some sort of enterprise and some sort of development environment where securely, or where everything will be available for you to be productive. For all the dependencies will be installed over there. Everything required for making or developing your solutions will be there. So basically, this is compute instance. Compute instance is your workstation in the cloud. This is the workstation in the cloud, your laptop in the cloud. And in this compute instance, they will install Jupyter Notebook, they will install Jupyter Lab, Visual Studio Code will be there. You can also will be having the terminal installed. RStudio will also be there. So whichever development environment you want to go for, you can use that one to make your solution. So you can connect to this compute instance. You don't need to have any dependency in your laptop, and from here you basically can develop your solutions, and you can run those solutions in the compute clusters. So I just created one compute instance, and I created one compute cluster, and they will be coming up very soon. And apart from that, we have the overview of the architecture. So in the meantime, when my solutions are coming up, I will just take you to the next step. So from the architecture's point of view, we have, this is the architecture of Azure ML. And we have compute instances, compute cluster. So compute instances are your workstation in the cloud. Compute clusters are the location where you train your solutions. Apart from this, what we have talked about is the data set. Data set is the metadata, and data stores are the location where your data really exists. The compute targets are also available. Like compute targets are the deployment targets, like Kubernetes cluster, the compute cluster targets will be in sense that you are looking for. So for example, it's not only CPU, GPU machines. We also have other options available. There are options in which I can do parallel computing over there. Azure Batch can be used. Lots and lots of different solutions can combine together with Azure ML. The object storage is over here. Container registry is the location where we keep the Docker containers. Key vault is for security purpose. We keep the secure keys. Like if you are talking with the SQL database, definitely the connection string will not be hard coded anywhere. We will keep that connection string in the key vault. Key vault is based on hardware security module. So security is very important. The confidential, the privacy of the customer is very important. The data which you are reading, that should be, if you are pulling the data and you are transforming the data, you are doing ML on top of it, then we have to think in terms of keeping it, you can say, confidential as well. The monitoring solution is called as application insight. Environments, for example, today we will be doing deployment with TensorFlow. So we definitely need TensorFlow to be installed. We will be using the Azure Machine Learning SDK, so that those versions, those dependencies should be there. Python version will be there. So everything I can predefine in one YAML file, and I can call that thing as environment. Whenever we run the models, for example, I am doing classification experiment, or I might be doing my regression experiment. Maybe we are doing some deep learning experiment. So all of them are part of experiments as such. We can stitch various steps together also. You can have, let's say, step 1 of the pipeline, step 2 might be the model training, or let's say step 2 might be the cleaning of the data. Step 3 might be running any transformation on the data. Step 4 might be doing the real the model creation itself. Step 5 might be registration of the model. Step 6 might be deployment of the model. So all the bits and all the various steps of any ML model training pipeline can be stitched together, and we call that concept as pipeline concept. So, and models are models itself, and everything which I'm accessing from the workspace. So where is my workspace? Workspace is the one which I showed you earlier, and let me open my workspace quickly again. So this is my workspace, and everything I can access will be available from this one location. So if I take you to the, for example, let me show you the compute part which I just clicked on. So you can see that my instance is running now, and I can click on Jupyter Lab, Jupyter RStudio, or VS Code or Terminal over there, and that's my Jupyter Notebook opening up in the cloud. So what is this option? This option is over here, like the cloud workstation. So it's ready, and now we can start the deployments over there. So this is where you can create the model, the code will come over. Now, before I go into the TensorFlow or the distributed training part, it's not only about as the question in the starting, like how can I start my journey with ML? Is it heavily depending on the programming languages? Answer is sort of yes and sort of no also. Why no? Because Microsoft provides innovative solutions. Like they have created this designer. So designer is something where you will be able to create your solution with no code environment, and this solution is as good as it can be. So you can, if you know what you're doing, within minutes, or you can say within, let's say, hours, you will be able to design a very effective solution. So if I quickly show that part to you, like just to show what do I mean, this is the designer over here. And how does it work? We basically, let's say it's asking me that, okay, Shivam, create one pipeline over there, design something. So let's have a quick small demo of that. Let me quickly create something for you. So as the very first thing is, I need my data. I don't have the data right now, right? There's it says that there are 0 data sets, so I need my data. So what I'm doing, I'm just basically clicking on the data set option over here, and I'll say create new data set. So I can create my data set from, I can upload the data as well. I can use data store, SQL, data lake, object storage. I can also go for web files. That's the one which I will be going for today. And I can also have any open data set, which for learning purpose, I can do that. So I'll just copy my data from my secondary screen. That's the link from where I'm pulling the data. And this data is, we are using this for the clustering as such. So there are structures in this data which we want to figure out. So I'm giving it the name Penguin data set, like that. Will it be tabular in nature? Will it be, is it going to have multiple files? This data set I'm going to load in Pandas data frame in the end. So I will create this data set as tabular over here. Now, when I click next, it will show me the details over there. Like it is doing the validation right now and parsing the data set information. Let's wait for this. Okay, great. What's the file format? It's comma separated CSV file. Is it TSV or any other file? Not really. Secondly, if you can look at my data set over there, the flipper length, the body mass flipper, the penguin's flipper as such over there, and the culmin length or the culmin depth basically is the beak of the bird. How big is it? What's the length of the beak of the penguin? Body mass, which species, and so on and so forth. But the problem is my column names actually went in the first row, so I'll change that. I'll say use header from the first file. So okay, now I think it's loading properly. So I have the column. The first row is the header actually. I'll just go next. And do I want to change any data type over here? Do I want to not take any column? If I feel that any column is creating noise in my data set, I may not take it further. So right now I have no such intimation. I will just go next. Now let's create this data set. So where is the data? Like, did I import the data? Answer is no. We didn't import the data. Data is still in the web link itself. We have just given the metadata and the location from where the data has to be pulled when we will run the solution. So if I go back to my designer now, right, that's the one which I clicked on earlier, right? We can name it properly from here. So let's say model creation. So we are basically doing clustering over there. So I'll be doing clustering here. So my data set is showing 1 over there. I'll drop it now. And on the right hand side, I saw the red mark. Let me just click on that and select my compute target. It's basically asking that, Shivam, where do you want to do the training afterwards? Like where do you want to do it? So my compute target is my compute cluster, the one which I just created. That's where I want to do the training of my solution. So right now there are 0 nodes, but it will scale automatically. I don't have to worry about that as such. Now, how do you want to, let's say, I'm just selecting some features over here. So select columns in the data set over here. Which column do I want to select? I can have that selected from the tab. So this is, at this time, it is actually trying to go and get me the data, so I can carry on with the next part. Which column do I want to take forward for my training? Actually, I want to show clustering demo. So I don't want the target attribute with me. I don't want that, because then if it is already there, then what am I trying to cluster for? So I'm taking all the other columns apart from that. Then is the data like, how is the data looking like? Can we visualize the data? We can. It's there embedded in the platform itself. So it's like 344 rows are there, 5 columns are there, and missing values are there. There are 2 missing values here. There are 2 missing values there. I think 0 missing values here, and so on and so forth. So some data is missing also, and right. So some data is missing as well, and we would like to clean that. So let's clean the data. Let's search for clean missing data like this. So what do I want to do? Do I want to impute my data? Do I want to replace with mean, mode, median? What do I want to do? So I want to, first of all, I want to do it on all the columns. I don't have any one column in mind. And then what's my cleaning mode? Do I want to replace with mean, mode, median, or remove the entire row, or remove the entire column? So right now I don't have any intimation why is the data missing over there. I don't want to create any bias in the model because of me doing some sort of imputation over there. So I'm just removing the entire row, and basically only 2 rows are there, so I'm not losing huge amount of data. If it would have been, if the rows, we only have 344. So if it was removing maybe 50, 60 or 70 rows, then that's a significant amount of my data being lost. So then we would have definitely gone for a little, we would have thought further into this, and we would have gone for, we would have maybe replaced with the average values, or maybe the modes and the medians and so on and so forth. Now I want to, so you might have heard about, or if you are going to do work with ML, normalization comes into picture. Like different scales will create if one scale is very big and the other scale or other metric is very small, then the metric which is very big will dominate the model training. It will create bias over there. It will the data will be squished on one of the axes as such. So I want to normalize my data. Maybe I want to remove that. I want to do min max over there. So by this I will be removing the dominance of the column which is having bigger metric. And so it's asking on which column should I do it. So all the columns are numerical as for now. So there is no strings over there. So I'm all good. And now how do I do the training? Basically, I'm looking for, so now this is the designer. So this is something which where your dependency from the programming languages is reduced, and it's more towards the ML concepts, the machine learning concepts. So this is something from where anyone can start their journey into the cloud. And now splitting of the data. So how much, what's my training data set size? So with 70% of my data, I'm doing the model training. So I have given 70 over there, .7. And my 30% of data will be used for testing purpose. So I have given 7. Do I want to do, when I'm splitting my data, does the splitting of the data is supposed to be randomized, or should I do stratified sampling over there? So all the options are available in various methods in which you want to do the splitting of your data. Now, which algorithm should I go for? So in this data set, I'm looking for basically, this is the location where you can refer to the code, the sheet which I was showing you earlier. Like what do we want to do? So we are looking for the data is basically we are doing clustering over there. We want to find similar data patterns. We want to find the simpler species of penguin together. So we will be going for clustering as such. And one of the lowest hanging clustering algorithm, or the one which we go for whenever we are learning ML, is k-means clustering. So this is my algorithm I have selected from here, and then I want to train my model. So it's basically called as train clustering model. Okay, that's great. So I'm adding it over here. So now which option goes where? Those things you will learn with practice. You will once you will play with it, it's pretty straightforward. You will be able to understand in which step what is going on and why are we doing that. And then once we have done it, I want to do some testing. I want to see whether when I'm doing clustering, what is the average distance of my points from the cluster let's say center. Is it a tight cluster? Is it something which is is it a tightly packed cluster? Is it good clustering happening, or do I have or interdistance, let's say the distance interdistance versus intra distance over there? What's the ratio of that? I want to have a look at that. So I will do my testing like this. And let me align this. So I just created that, and right like this. So my logic, the one which we are trying to deploy, we can use designer also to do that. So this is like why cloud comes in ML path. Now I want to train this model. My cluster was already created. I created it earlier, so I'm saying submit my run. So it is saying that, okay, create one experiment. Like the experiment needs to be given over there. Like, what are you doing? So I'm saying, okay, create one new experiment for me. I was doing the clustering. I was doing clustering over here. So let's say this model is where I'm doing clustering. So penguin-clustering is my experiment name. So now I'm going to submit that. And it's select the default compute is already selected. So the submission is going on. So we'll just wait for it to submit, and we will come back in some time to check what has it done. Is it finished running or not? But very soon, as soon as it says the run will start very soon, and you will see that step by step, each of them are executing, and they are doing what we have designed them to do. Once the model has been trained, you can deploy it also from here, And now you can see that it has already started doing some sort of processing. Okay, now we'll leave that training to happen over there, and we'll go back to the slide deck, and let me just quickly go back to the one where we were. So yeah, okay. So what is designer? I showed you the drag and drop option over there, but is designer the only option do we have, or is designer sufficient, or can designer do everything which we want? Answer is no, not really. So designer is very good if you are getting started with ML on cloud. So you can drag and drop, you can create your solutions. It's amazingly fast. It's amazingly self-explanatory. You can present it to your managers. They will also understand what's going in which step. They don't have to go through the endless stupid notebooks. But designer doesn't have all the features yet. In future, maybe there will be all the features over there, but a lot of things which I want to do, I will not be able to do with the designer. For that, for now, in this point in time, we really have to go in the Python part, where you have to write your Python or R code as such, and that will run. Now, coming to the second part of the session, what will you do? So see, now these machine learning models are the one which I just deployed, that hardly will get, when that will be created, that model hardly will be of it will be in KBs as such. Pretty small model. There is no problem of there is no memory problem over there. There is no CPU or GPU problem, or there is no memory outage or running out of memory. No error is going to come as such. It's basically will execute in this very smooth flow as it can. But what happens when your models are big? When we are training the deep learning models, they may end up being very big. Or secondly, your data might be very big. Your data is so big. Or if you have trained, so I used to train face classification models on my laptop. It used to run for days, and at maybe at 1 week like that. So when you are doing your model training, if it takes let's say 1 hour to train, it's okay. If it takes 1 day to train, then you are a little worried about it, that okay, if you made any mistake, then you can change it only tomorrow. If your model take 1 week to train, then, and if you have done any mistake somewhere, you want to tune another hyperparameter, you want to change some value somewhere, that is something which is very expensive from the hardware's point of view and from the time's point of view as well. Secondly, if your model take months to train, then there is really it's really difficult. So what do we do when the model is very big, right? When the data is very big, what do we do practically? So we will go to the whiteboard to understand the distributed nature of the offerings which are there. So let me open a new whiteboard and check this out. And in the meantime, the models are training at the back end. We'll see them afterwards. We'll go and have a look at them. What are they doing? Okay. So notice this. Now, what do I do when my data, or when we how can we train a model that is too large for a single device, right? There are two options which you can go for. One thing is called as data parallelism. Second thing is called as model parallelism, like that. So I can make the models in parallel manner, and I can go for data, and I can go for the parallel model creation over there. So let's talk about this. Okay. So what is model parallelism as such? Now, basically what happens over here, we are talking about machines over here. Let's say this is M1 machine. This is, let's say, my machine number 1. My model is so big. My model is in GBs, imagine, right? Or it may be so these days we have CPU and GPU which have enough amount of memory over there to be able to hold model. So if you are going for something which is very giant, then you might need the model to be created parallelly on different machines as such. Otherwise, otherwise not. So what happens when I have the model which is parallelly trained? Basically, these are my various machines. What do I mean by machines? Maybe virtual machines in Azure Cloud, or maybe any multiple machines which are there. These might be having any accelerators. They might be having GPU over there, or maybe TPU as such, or CPU will be there. So when I create my models are distributed in multiple machines as such. Check this out. So this is my deep learning model, and it is having a couple of layers as such. And the layers are in various machines over there. So I'll just add them over here, something like this. So when I have the model parallelism over there, basically multiple machines are used and the models are distributed over there. Secondly, if my data is very big in size, so imagine this is my data. So this is my data over here, and this is a huge amount of data. So what happens in data parallelism over here? We will be having multiple machines. Let's say this is my M1 machine over here, and that's M2 machine, and this is M3 machine. Like this. So there is a subset of the data. You see, this is a subset of the data. One subset of data is for this machine, one subset over here, one subset over there, like this. And this is my machine 1, this is my M2 machine, and that's M3. So some of the data is getting trained, or one subset is being used over here. One subset of my data is being used over here. One subset of my data is being used over here. And where is my model? My model will be there inside the machine. So this is my model over there. So that's the same machine, let's say deep learning model, and I'll just represent like this. So like that. So there's the same model which is there in all these machines. And let's make it one more time. Right, let's put it like this. Now, as you might be thinking that in machine learning, it's all about the weights. It's all about the parameters over there. It's all about you can say forward pass and the backward pass as such. Where are the gradients? Where are we doing the loss computation? So who's synchronizing or who's managing all these machines which are training the models parallelly? Basically, here one parameter server will be there. So this is called as central parameter server, or global weights will be there, or basically this is a parameter server. So that's the parameter server. So what these individual machines or models will be doing, they will be pushing their weights, whatever weights are there. Let's say W1 for this, that's W2 over there, and so on and so forth. Maybe this is W3 as such. So weights are being pushed to the parameter server. The parameter server will be doing the gradient, will aggregate all the data. It will aggregate, it will find the gradients as such, like should we increase the, what's the deltas which we need to do. It will broadcast that, the gradient back to the machines, and then like this. And then these machines will update their weights locally. So whenever we go for parallelism in data as such, the parameter server can become, this is central in nature over here. Now this central model this central parameter server may become a bottleneck as such, because we understand that the GPUs are very, very fast versus GPUs. Communication from one machine to another machine will be slower. Secondly, one problem, like this is one single machine. So if I scale out my solution, if I add more machines over there, the network load on the parameter server will increase in multiple folds as such. So there is one approach which we take, in which we shard that database. So basically, this is a key value store. Parameter server is a key value pair or key value storage. It's mostly implemented like that. Now we shard it over. So what's the meaning of sharding? We break it, and there is a Now we create, let me just make a dotted line over here, and let's say this is the parallel server. So now what do I have? I have multiple machines over there. These are shards which I have created. Maybe there is a master node over there. So this is these are various server nodes over here. And now I just created a parameter server group. So this is the parameter server group. So what have we done over there? Now that network problem will not be so significant because we don't have one central server. We have multiple distributed key value store, or this is the sharded key value stored. So we have sharded it out, or we have partitioned or broken it into smaller pieces. This is the key value store. So all the various machines will be talking to this distributed key value store to be able to get the gradients. And what is this circle over here? That's the master or the manager. Basically the one which will be making sure that all of them are continuously in sync and they are talking to each other. So whenever my models are very big to train, I have these two approaches. I can go for the parallelism over there in model, or I can go for the data parallelism as such. And my machines might be in different, my model might be in different machines, or my data might be created, or they might be subset of data which we are training in different machine at the same time. There is one more approach in which we can merge both of them together. So some of the frameworks, they support that. It's basically called as like you merge both of them together, and you have the model parallelization plus you also do the data parallelization at the same time. So everything is running in parallel over there. Right, so check this out. Let me quickly select it over here. So what else can we do with my data? This is the data over here. So now if you have multi GPU nodes with you, effectively, let's say this is machine number 1 and this is machine number 2. You can do the parallelization both at the same time. So over here, this is my one, I think I should make it in vertical like that, the way we had it. So one subset of my data goes here. This is subset. Another subset of my data goes here like this. And these are multiple GPUs over there. So this is one GPU, that's another GPU. And maybe we'll pair it out. We'll put 4 GPUs. So let's say 2 physical cards are there with 2 GPU each. And like this. And my model is somewhere in here. So this is my model, which is also running in multiple GPUs at the same time. So we can have the parallel data approach plus the parallel model training approach together done at the same time. So various approaches are there. Now, here we have to understand that which scenario should be used in which for which problem statement, or what are the pros and cons of whatever we have talked about till now. So if I talk about the parameter server over here, in whenever you have the data parallelism in consideration and you make the parameter server, the communication to the parameter server is very, very important. So how are these machines talking to the parameter server? Like, is it synchronous in nature? Is the communication asynchronous in nature? That is something which is of great importance for us. So there are 2 types of solutions which you can do with the parameter server. You can go for synchronous communication or asynchronous communication. So check this out. Over here. So with parameter servers, now if I go for synchronous, let's say this is synchronous, and here I have asynchronous communication. So asynchronous communication. Now there are pros and cons of both the approaches. Now whenever we have this synchronous communication with the parameter server, the problem is the entire model is the entire training or entire step is as slow as the slowest machine. So imagine these are my three machines, and this is the parameter server over here. So the machine number 1 and the machine number 3, they very quickly they were able to push the data. They were able to push their weights into the to the parameter server over there, and they have informed the parameter server, and maybe we are doing regression over there. So maybe there is some sort of aggregation going on. Maybe something like this. Let's say weight 3 and x3 over there. So, but the problem is the slow machine, the machine over here which was taking more time. The machine there was a delay in the you can say there was a delay over here, and because of that the entire step is waiting. So the parameter server cannot broadcast the gradients back to the machines until and unless all the data, all these different weights are received by it. We need to have W1, W2, W3, all of that needs to be there. So in synchronous communication between the parameter server and the machines, because of the slowest machine, the entire process is delayed. So the trade-off between doing the distributed training versus the delayed network communication, the delayed network communication becomes a bottleneck. Now, in the asynchronous communication, what happens? These machines, they talk asynchronously with the parameter server. There is no synchronous communication as such, and they are just sending their updated weights, and they are receiving the gradients whenever they have finished it. So asynchronously they talk with the parameter server like this, and it's sending the gradients back. Now the downfall of, so the good thing about asynchronous communication is that definitely now we are not the slow machines are not delaying the entire process. But the problem with the asynchronous approach is that now we are working with partial gradients over there. The weights are not totally aggregated correctly. This is where we use the partial gradients, and because of the partial nature of the gradients, this is the partial updated weight, and because of the nature of that, it takes more time to converge. The converge will happen way slower, and it also the model will also be very unstable. The model training will be very unstable. It may go up and down, and it's pretty unstable as such, like this. So there are two very popular approaches which we have just talked about. In parameter server, you can go for synchronous, asynchronous communication. And the problem with synchronous communication will be that there can be delay due to the slow machines. But the workaround which we do over there is that we put a timeout period. If the machine is delayed a lot, we do the timeout and we remove this machine from the rotation. This machine is now removed, and it doesn't slows the process beyond one point. The problem with synchronous parameter server is that basically it takes more time to converge. So the training time will be way longer. Now there is another approach which we can take, in which we don't use any central parameter server. We distribute the parameter server, and it is called as all reduce. So this is something which you might have heard before, or if you have worked with Horovod basically does all reduce. That's something which is built on top of it. TensorFlow also can do it. It's not that it doesn't do it, but definitely Horovod is one of the framework from Uber which was built, which innovated the all reduce approach. And what happens in all reduce is basically, instead of using any central server for what was happening till now, if we think it through, multiple machines were pushing their data into one central machine, and then they were waiting for the broadcast of the updated gradients or updated weights over there. So all of them push the data over here, their weights, and then they are waiting for and this is that machine number A, and then they are waiting for the central parameter server to be able to respond back. Now, instead of that, in all reduce, what do? We distribute that. We don't have any central parameter server. Instead of that, the job of aggregating the updated weights is distributed to all the machines. So this is my machine A, machine B, machine maybe C, machine D. Now there is no central server. They can all send updates weights to each other, They all have some partial weights with them. They all are passing the values to each other like that, and we basically have a everyone talking to everyone. So distributed aggregation on all machine happens in all reduce. So this is distributed aggregation. Like that. Now in all reduce, there is one approach which is very popular called as ring deployment. So what happens in ring based deployment? Basically, instead of all the machines talking to all the machines, they talk to the next machine in the ring. So the architecture is created in ring manner. So this is one machine. That's the second node over there. This is my third machine, and let me just say, let me put C over there, and let me put D over here. Now the communication will happen in this manner. A will talk to B, B will talk to C, C will talk to D, and D will talk to A, like that, in ring format. So what happens over there? Like, why is this so significant? What is the meaning of this ring approach? Why is it significant? What happens? And how we will be doing it, and so on and so forth. For that, I will just take you to my slide deck and have a look at this. So please have a look at this. So the machine A had the weights, and this is machine B. Machine C had its own weights. Machine D had its own weights. So all the different machines, they start with their own parameters. Now in ring manner, A will push some weights, some to the will pass that weights to B. B will pass to C, C will pass to D, D will pass to A. So you will see that the A weight, which was here basically, this has been passed to the B, and now B is doing some sort of partial aggregation, and B has passed B1 over here to the C machine, and then C has passed some data C2 to the machine, and then D has passed has done the communication to A machine. And then in step number 3, you will see the process again repeats. Now again, whatever aggregates were there, so these two values in the step number 2 is passed over there, and those two values are passed here, and those two values are passed here, and those two are passed here. So you will notice that we have more aggregated weights now, and the communication still continues. So in the step number 4, the different machines, they are doing bits and pieces of the aggregation over there. Now once they have done this, they will have the updated weights. This is S1 over here, that's S2, S3, S4. Again in ring manner, they will pass the weights around. So this will go there, that will go here, this goes there, and that goes here. So we will have S1, S4, S1, S2, S2, S3, S3, S4. So when the process finally finish, at the end of it, everything, all the machines have the updated gradient. So this is the updated weight, and all of them have it. So there is no centralization on any parameter server, all doing mapping and reducing at the same time parallelly to each other. This happens in the ring reduce. Now, when we talk about Azure basically let you import any framework over there. TensorFlow, you may have Keras as well. You may go for PyTorch. You may have any other framework which comes to mind, Horovod as such. So Azure ML will let you import all of them you can say for you to use with Azure. But there are some basic boilerplate code. If you work in Azure platform, you need to know that. So for example, my very basic boilerplate code will be like, how do I connect to my workspace? Connect to my workspace means like I created the workspace in the cloud. I want to write my Python code. How do I connect to it? So some bits and pieces will always remain same. So from the point of view of DP-100 certification, it is very important for us to be able to understand the code which is a boilerplate code over there, which always remain, or the SDK which is Azure oriented. So in DP-100, lots and lots of orientation will be towards like, how do you do this in the platform using Azure ML SDK? And definitely you should also understand how to do it, or why are we doing it. So we are connecting to the workspace. Similarly, you can create compute target. I showed you before from the GUI, we can also do that from the script as well. We'll see that. The Python environments are there are two type of environments. One, Python environments are already available. We have the ready-made environments where TensorFlow is pre-installed, where Keras is pre-installed, where PyTorch is pre-installed, where Horvath might be pre-installed. Or you can also pip install your requirements. You can also conda install your specifications. You can do the requirements. You can pass the requirements in text file. You can also do inline. You can also pass the requirements in YAML files as such. Write the YAML file, deploy it, make a container out of it, and then use the container again and again for various purposes. When we run the configurations, we basically have one higher level construct called as script run configuration. So script run configuration is basically the object where everything will come together. Like where is your where is the code? Where is the train file? Where is your train.py? Right? Where is it? In which location? Which path? Is it in the local machine? Is it on some object storage you want to pull over some URL, or is it in GitHub? So the relative path will be required to be able to pull that from that location. What is a script file? Like basically, if I put the arrow correctly now, I think this goes over there. That's just the directory. Like which directory are you, where your code exists, like that. What's the compute target? Is it CPU or GPU based? Which environment are you creating? GPU based, TensorFlow, CPU based. Any input arguments at runtime. If you want to parameterize, let's say you want to create any parameterized script, then how do you do that? Creation of experiment will be there. We submit the run. So this is where the model training happens. So this is where we train the model. So after creating all that, we will say the submit. We submit the configuration file and the model start training. Connecting to the data store, connecting to data set, passing the arguments during runtime. This all of them is part of Azure ML SDK. So is it very complicated? Answer is no, not really. So the parameter server approach, which we talked about, right? That when it is implemented in Azure, it's something like this. We have this script run configuration. You are specifying your which directory your data is. Sorry, which directory yours is where your the files are, training files. Which script are you using? How many GPUs do you have? Like, is it single GPU or is it multi-GPU machine? How many training steps do you want to do? 500. So how many worker nodes are there? So basically what this means is worker node means like I have two machines with one GPU each. So this is like two machines with one GPU. So one GPU here, one GPU there. How many parameter server do I want? Is it centralized parameter server or is it going to be parameter server group, decentralized sharded parameter server? So we can select that. So we can just say, okay, parameter server count, I want 1. So one parameter server gets created. If I'm looking for some sort of, I think I'll show this second part. I think I pasted both of them same. I'll show the all reduce in the demo. Let me take you to the cloud then. Hang in. So both the pictures are same, and okay. So I'll take you to my Azure machine learning workspace and let's have a look at that. And the model got trained. This is the previous model which we were deploying earlier. This is that model. It is deployed over here. And basically, if we require, we can deploy this directly from the designer itself. And if we want to visualize the outputs, the results will be over here. The cluster distance will be visible over there, and the distance to the cluster, the center, and the distance to the other cluster center, and so on and so forth. So I didn't give the k-mean value over there, but over here I think I gave default it was 2 only, and definitely we want. I was thinking of 3 over there. So we can submit the run again, and it will do the clustering the way it was supposed to be. Now, what I'm doing, I'll take you to another of my workspace which I have pre-deployed, and this is the one which is the backup one which I have it over here in case the first one doesn't runs. And in this one, the same way we have created the workstation in the previous workspace, we have the workstation running, and we have the models also over here. And let me just refresh that to see, is it loading properly? Okay, so that's the one I was showing you before, the parameter server approach. So let's have a walkthrough of the code as well. And you will notice that we have talked about this bits and pieces earlier. Like, we are importing the Azure ML SDKs. Then we are initializing the workspace. What is this workspace? This workspace actually is getting loaded. So this workspace is this workspace. So the Python notebook is connecting to the workspace right now, and it's properly loading it up. And we are attaching the machine learning compute. So I have attached standard NC6, which is basically having one GPU itself. Half of physical card is there, not even the full physical card is there, like half of it is there, Tesla K80, and maximum nodes are 4. So 4 nodes will be there. And let me take you to the parameter server part. This is how we define the environments. Now I want to use one pre-existing environment where TensorFlow 1.13 with GPU version is pre-installed. So I don't have to define my dependencies, they also exist, and I can definitely do it again as well. And how do we do it? So the parameter server count equal to 1. So the workers will be 2, and number of GPUs are 1 per worker. And when we submit this job, we just say that run experiment.submit, and this piece, bits and pieces, are specific to Azure ML. So over here, and then we do the monitoring of our solution. So this was running for somewhere around 6 minutes. And so what can we do? What can we try further? We can give the next version. So for example, we have given 1 GPU machine. The next machine will be having 2 GPUs, like NC12. So if we run NC12, then NC12 will be having multi-cores. So I will just come back, I will change this to be, let's say, 2 over there. Now worker counts, we also want 2 only. Let's keep it that, parameter server 1. And we will notice that how much difference has happened. So the previous model was training for 6 minutes as such. We'll see whether it does a good job this time or not. And I will just say run all for now. Okay. In the meantime, let me show you the all reduce approach. So we are using Horovod. Horovod is from the Uber, the team Uber, and Horovod is used with multiple. It can be used with Keras, also with TensorFlow as well. And basically, this is the one which is using the all reduce approach. And the rest of the boilerplate code will remain same. We are importing the Azure ML SDK. We are initializing the workspace. Same Azure ML compute instances are getting attached. We are going for 1 GPU machine. Maximum nodes are 4 over there. And apart from this, if we go to the main input, which gets changed over here, now over here we are giving the MPI configuration node count equal to 2. So now this time what will happen, there is no parameter server which we are going for, and we are specifying how many nodes are there. If we want to have the parallelism in model as well, I can give the configuration called as process count per node, like how many processors, how many GPUs are there per node. And when we submit the job, and so basically you get the equivalent result, and so on and so forth. So the other machine which we were running, this is still going on. So how does it work? Basically, it's waiting for the run is going on now, and the job is queued. So because it is resizing the machine right now. So if I take you back to my Azure machine learning console. One of them is, so this is the GPU cluster, and it is doing the active run right now, and it is resizing. There is one change I just want to make over there. And let me just name it something different. I think it didn't resize to the correct instance. It went for the default one because the name existed. And we'll just give it something else over here. Maybe I think 2 doesn't exist. So let's put it 2. And let me cancel the run manually from here. So let's see if I can just cancel this run. Oh, okay, amazing. Now we will run it again. So what went wrong is actually I didn't renamed it. So the cluster was already existing. So it found the cluster. So new one was not created. So it was doing the deployment on the same single GPU machine, not on the multi GPU machine as we were thinking of. So let's run it again, and we will just go for run all, and we'll wait for it to happen. Okay, so it will take some time. The new compute cluster is coming up, and if we go back, we'll be able to notice the change over here. And if I go to the compute part and my compute cluster, GPU cluster 2 should be coming up, and it is having standard NC 6 machine, and it will take some time for these machines to be spinned up, and then the training will start. So we are expecting some delay over here for the machine startup time. Then the run will happen. In the meantime, let's go and have a look at the containerization part of it. Like, how do you containerize the solution? So I have another notebook over here in which I am using TensorFlow. The only difference which we are doing is we have a different data set. We have basically this is we are using MNIST data set, and handwriting detection is what we are doing. So a small neural network is getting created, and as part of this neural network, we are containerizing the neural network once it is trained. So in the first part of the notebook, the same model training happens. And if I will just go to the deltas over there, we attach the ML compute, we train the scripts, we do the model training over there. And let me just come down over here. Now check this out. So the model which was created, okay, so what are we doing? The model which was created, we are registering the model over there. So this model which was created, this will register here in the model registry. So if I go to the models over there, you will see that we have multiple versions, and I feel that this might be the last run which I might have done a couple of hours back. So if I click on it, that's the last one which we ran, and the model got saved. So if needed, we are going to put that into one container. So we are going for Azure container instances, and as part of our diagram which we have created earlier, what we are talking about right now is the extreme right side over here, where we have the deployment targets, and the score file will be written in one of the intermediate step. This score file basically contains the initialization, the model loading into RAM, plus the run function over there, which will do the prediction on the input data. So the model is containerized, and it is pushed over here in the container instances, and it is running over there. So we are deploying the model in ACI. How do you do that? Is it something which is very complicated to be done? Not really. The model registry takes place over here, and after that we are writing the score file, and the score file basically contains the initialization and the run functions, which will do the prediction. And we are creating the YAML file over here, which will have the dependencies. We want that in the Docker container, NumPy should be there. So in this container, NumPy should exist. TensorFlow 2 should be there. Azure ML default SDK needs to be available. And all of this we are saving as one YAML file. And once it is saved, we can use it again and again for various purposes. Then we are creating one CPU container instance with 1 GB RAM. and using the same environment file and the score file, we are doing the deployment of that in the deployment target. Now, once the model has been done, I think let me show the backup file then. Give me 1 second. Oh, sorry. Let me find the backup file and let me see which one is it. Oh, sorry, that's the folder. And now I am going inside and let me check. Is this the backup one? Let's have a look at that. Oh, no, not really. I think that's the same file. I'll find the backup in the meantime. So basically what we have done over here, we have done the score.py, and as my backup, if I go back to my Azure, if I open my Azure portal back again, I have the model running over there. So I'll go to my resource group and I will show you from there that in the resource group called as webinar demo 2, which is the backup one, we have the container instance running over here. So what is this container instance? This is the location which we are talking about here, where we have done the deployment in this location. So once I click on it, you will be, so nothing is visible as such in this, but if I go to the containers, my trained model is running in this location. So this is that TensorFlow MNIST source location, and some images are there. And basically we have pulled some base image and it's running there. So the job is running continuously, and we can do the scoring against that. So we, I think if I go to the, let's go to the slide deck back again, and let's have a look at the model training which we have deployed. Let me go and have a look at that. Is it finished or is it still deploying? So do we have to wait for that? And let me just check that out. Okay, the correct file with me. Oh, this one. Okay, so the training is still going on, and this is the approach where we have the parameter server created, and the node is still running, and in the starting some time is there in the starting of the node, plus then the running time of it. So this will go on for some time. And once this is deployed, once this is trained, we will be able to containerize that. Okay, that's great. So now just FYI, there is not much of significant difference in the previous model training versus this. So basically what we were thinking actually happened over there. Like in the parameter server approach, one of the bottleneck which occurs is the synchronization which happens with the parameter server. So over here, just by increasing the number of machines over there and having single parameter server and all of them communicating to the single parameter server, at times doesn't end up in you can say lesser time, because the trade-off between the distributed scaling versus the communication is a main trade-off, and because of that there is a bottleneck which gets created. So we have noticed one thing, that it took literally sort of same amount of time. It was somewhat 6 minutes earlier also, and it was 6 minutes with multiple GPUs as well. And then this is with a parameter server approach. Now if I go back, so this is basically what I had in the demo for you. Now I'll just do a quick walkthrough of the slides which I have with me. And if I take you to the certification path, like in DP-100, what type of questions are coming, what type of things are coming, you must have realized that this is something which is more oriented towards data science or machine learning, and cloud plays some factor over there. However, DP-100 is the one where you need to be aware of to clear the certification, you have to learn about the algorithms. Cloud knowledge should be there. Specific Azure ML understanding comes into picture. However, using the tools such as Designer, things become more streamlined and you can say easy to work with. Apart from that, there are other approaches as well. There is one certification from Microsoft called as AI Engineer, and the AI Engineer certification is basically focusing on the chatbots. Here we create the chatbot with C# as such, and in Data Scientist we basically work with custom machine learning model creation. Some other approaches, some other trainings are also available from Microsoft, where you do the data engineering, ETL pipelines, ELT pipelines, or big data Spark cluster. That is basically covered as part of data engineering. Anyone who wants to work with the visualization track, the analysis track, the storytelling with the data, this is where we work with Power BI in data and DA100, and visualization comes into picture. Apart from that, there are some other tracks in Azure. For those who are starting the journey with the cloud platform, it is recommended that you go for the one of these two, either the administrator on Azure or the developer on Azure, because they will create a solid foundation for your knowledge building, which may be required for other trainings. There are security tracks available where if you are concerned about if you have to work with the hardware security modules, and if you are the identity management itself, the just-in-time access, elevated access, any privileged identity management, or the vast security field, then AZ500 is there. For DevOps, there is a certification called as 400, and this is where you will create the CI/CD pipeline with multiple solutions. Now, another expert level certification which exists is called as 303, 304. So these two certifications together, they end up in, so if you're looking for solution architect, if you are targeting solution architect certification in cloud, then these are some certifications which you can go for. And so what I have told you are the associate and the expert level certifications, but the journey starts from the fundamentals, definitely. So those who are looking for getting started, maybe Azure Fundamentals AZ900, or maybe data fundamentals, where we talk about the different type of data is the starting point, or maybe we have the AI fundamentals, where the basics of the machine learning comes into picture. So if for those who are new to the cloud, it is recommended to go for maybe AI 900 or equivalent knowledge, and then maybe jump into the next one. So there is no hard and fast rule from Microsoft, but the learning is more streamlined, more step by step. So these are some fundamental level trainings as such. Now we also do the instructor-led trainings, and the trainings, they generally are on weekends. 4-week programs are there. The next batch is starting from 29th May, and the batch is on Data Scientist DP-100 track itself, where we talk about, so this is just like 2 hours of session over here. However, in the training it takes more time. We go in more depth, we cover more algorithms as such. Apart from that, for training purpose, we offer the Azure passes for everyone to do the labs. These trainings which are developed, or you can say maybe developed or deployed or maybe delivered by TechScalable, they are mostly hands-on based, and everything is case study oriented. there are case studies which we solve, and the scenarios which are deployed during the training. So for that location where you are deploying it, we give you the $100 passes, and these are Azure subscriptions, and you can do the entire practice over there. And apart from that, we also provide practice test for clearing of the certification. If you're targeting any certification, you would like to have the solution, you can say the questions as well with some explanations and answers of it. So verified questions and answers, and the questions which are aligned with the certification, we do provide that. And we also provide the hand holding and the post training support during these batches.
Hey Shivam, thanks a lot for explaining such beautifully the entire deployment and executing the entire training pipeline. It was really nice looking at it, and a lot of people are asking questions like whatever code you have used, would you be putting in the GitHub repo? And there was one more question which I want you to answer. There's a question from Samar Nika. Is there any basic AI ML course along with DP-100 that we offer at Tech Scalable? So can you just reiterate? I know we were discussing in the beginning of the session about the prerequisite, because it's a bit difficult topic. People obviously want to know what would be the prerequisite, what they should come ready with in case they are planning to enroll for a DP-100 program. If you could just reiterate that, that would be really good. I know you showed the certification path, but...
So yeah, definitely. So now DP-100, this training is 4 week long. So what do? We suggest the participant to join us at least 1 month ahead of the starting date of the track. So in this 1 month, what we do, we provide the you can say the fundamental tutorials, the self-learning videos and links, and so on and so forth. So, and we provide the support over the WhatsApp group, and if you get stuck somewhere, if you're learning something, so we cover the basics of things, like the basics of Python for let's say data science, the basic of Python for Azure, any basics of machine learning which you may have to go for, what is supervised, unsupervised, semi-supervised learning, and so on and so forth. Or any other mathematical small basics which are there, maybe what is matrices, how do we do transpose of the matrices, or any type of basics are provided. Mm-hmm. So now coming to us around let's say 1 month ahead of time, or at least 3 weeks ahead of time, they get enough time to be able to go through that, we solve their problems, and so on and so forth, and then they are ready for the training. And once they take the training, they are you can say we have aligned them with the cloud-oriented ML.
So you would say that because we are starting March 29th our batch, so 1 month ahead, like April 29th would be the good time when people should enroll for the program, correct?
Yeah. Yes.
So I'll just pass on one more message to the people, those who are still tuned in. So we are running a 1-day offer on this particular course, which we are offering the DP-100 for today, and like for 24 hours, for the next 24 hours, our course would be available in $199, and it's like a one-time opportunity. It's a 4-week, as Shivam said. It would be run during the weekends, 7:30 to 11:30 p.m. IST. Kopal, if you can post in the details on the chat, that would be really helpful. And it would be spread across Saturdays and Sundays. So 4 weekends dedicate to us. And as Shivam said, come 1 month before, try and learn the basics, which would help you really learn the actual ramp up for the course and be ready to learn DP-100 curriculum content. So that was about our DP-100 program, which we would be starting shortly on May 29th. Shivam, if you can help me with the next slide. Yeah. So we have our upcoming webinars as well. On 27th of April, we are doing a webinar which would help you learn about Kubernetes. Shivam was also showing a few things about Kubernetes, right? These days, Kubernetes has become like a de facto to run our applications. Let it be a machine learning application, let it be a web server application, let it be a database type of application. Any sort of application, default is containers, and managing containers is Kubernetes. So this is really catching up in the market. So we would be explaining about what exactly you need to have for getting certified as a certified Kubernetes administrator or application developer. So we would have a 2-hour session like this on Kubernetes on April 27th. In case you're interested, you can find the details in the chat. Kopal would be posting shortly. And you can also tune in to our YouTube channel. We keep posting our webinar recordings over there. We have our Tech Scalable web page where you can subscribe and you can keep getting details about the upcoming webinars and sessions which we have. Shivam, if you can, yeah. So we are coming up with a training program as well, which is again for Kubernetes, how we are doing a DP-100 training. Same way we are doing a CKA and CKAD training program. That is starting on May 1st. And those who would be enrolling today, they would be getting $390 offer for enrolling for the Kubernetes administrator track. And in case you want to do both the certifications, you might have seen a trend on LinkedIn that people do both the certifications together because there is a delta between both the certifications. You can think that there's a 70% common content and 30% extra you learn for admin, 30% extra you learn for the application developer. So if you enroll for both the programs, the cost of the training would be $490. And if you just enroll for one, it would be $390. It would be 8 weekends training program. And if you're enrolling for both, then you would have to spend 2 more weekends with us. So as Shivam said, it's all hands-on oriented. It's all case study driven. You saw that Shivam was more into portal explaining stuffs by doing it. That's the way Tech Scalable delivers the training, by showing the demo, making them people learn from the like doing the activities, just not running through the slides and explaining or iterating something which is written in the slides. So that's the way we deliver the session. In case you're interested in any of the training programs, you can drop us a mail and connect with us on LinkedIn. Shivam, if you can just write Kopal's, yeah. These are the email ID and the phone numbers. You can even WhatsApp us on this number, give a call or drop us an email at sales@techscalable.com. We can help you with the details. There are few questions. Do you help getting jobs once certified? Akash, we don't help you getting jobs. We don't provide job support, to be very frank. And if you go back and see the offers which other training companies or training providers are providing, it's all fake. No one can promise you a job. We can help you learn or gain knowledge in that technology, help you master that technology, but providing job assurity is all, I would say it's all fake. People do that, but you can go back and check. It's not like it's never works out. What's the cost if you're not enrolling within a day before 29th March? So Samarnika, the cost would be going up. It's actually $249 course. We would be providing in 24 hours at $199. So you would be losing on $50 in case you're not enrolling in a day. So just block your seat so that you have that one month's pre-learning phase as well, and ramp up quick for getting certified on DP-100. Webinar recording also is available. We would be sharing. You should receive email from us within an hour after the session, and you should have that recording on our YouTube channel as well. Arvinda was asking, post-training support is for how many days? There is no confined time frame, Arvinda. The channels or the WhatsApp groups which we create, I would say that me and Shivam have been delivering training for 6 to 7 years now. and we even reply to the people who had got trained with us till date around 6 years back. So it's just not, there's no expiry date related to the post-training support. It's just that you ask us queries and we reply you back. And it's just a way of saying thanks for enrolling with us. So it's like a journey you cover with us once you enroll. Yeah, so that was about our sessions which we are coming up, webinars which we are coming up. Anything else, Shivam, you would like to say or answer any of the questions which are there in the chat?
Yeah, definitely. So I think we ended up little in time. We still have 5 minutes. So if there are questions, we can definitely take those questions.
So yes, there are a lot of people still there on the call. Guys, if you have any questions, please post in your questions. We would love to answer them. So there are a few questions. Shivam, if you can pick up. I am new to ML and AI, but training was quite helpful and clear, Samarnika is saying. She had few questions with respect to prerequisite as well. So Samarnika, if you have any further questions, you can directly connect with us on LinkedIn and even drop a message to Shivam on that. Shivam, we had a quiz program after the session. So if you can just pull in the questions of the quiz, that would be helpful.
Sure. Yep. So what I'm doing, I'm putting the quiz link in the chat window.
Yep.
And so let me just quickly put that. Okay, so I think I am able to send it to the organizers. So I'm just sending it over there. If you can just repost in the public chat. Okay, so guys, go through these. It's a small quiz, and the winner of the quiz will be getting the certification voucher. So the questions are on basic machine learning. I am
unable to post it, Shivam. Kopal, can you just post that in the chat? That would be helpful. I'm unable to click on the chat window. No, it's go to webinar is stuck. There's a question from Prabhu. Unlike other exams, CK and CKD is a performance-based exam. So how do we prepare the candidates? So we have completely hands-on driven classes, as Shivam was saying. So we do lab exercises in the class. We make you do hands-on practice a lot, learn the basics so that if there are any twists and turns in the question in the exam as well, you should be able to handle that. And we even provide some practice tests of hands-on guide so that you can run through them and post, or like you can go and practice and then prepare for the exam. Kopal, if you can post the quiz link on the chat. Shivam has shared in the...
Sure.
Yeah. Sorry, I'm unable to post that on the... my GoToWebinar is not responding. Sorry for it. Shivam, if you can pick Gunashekharan's question, would you cover just AZ ML concepts part of DP-100, or you would include core ML concepts as well?
Now, there is without core ML concepts, it's not technically possible to cover any machine learning training or work with machine learning without understanding the core ML concept. But as we already understand that the core ML concepts can be based on computer vision. Maybe the core ML concepts, they are going in classical machine learning, or maybe they're going in deep learning. So anything which is part and parcel of DP-100, the defined outline from Microsoft, we cover it out. It may be the mathematics behind it, or any core ML part over there, till the deployment or the ML ops over there. So we do cover everything which we explain everything which we talk about, and we do the hand holding like that.
Great. So Gunashekharan, hopefully your question is answered. We do cover the basics as well of the models. Otherwise, it's pretty difficult for us to explain how it works in the cloud platform. So we do that. Shivam, can you just check the message in the chat is reflecting on the quiz link?
Yeah, I can see the message over there. So everyone, there is a quick quiz link in the chat. If you open it up, you should be able to give the answers over there. Now the quiz is basically on basic machine learning, the various matrices as such, what type of techniques are there. So if you work in data science, if you are coming from that background, you may find it to be very easy. But if you are learning it for the first time, it might be challenging for you. So take your time, do answer that, and we will be announcing the winner of the quiz on the LinkedIn page. So to subscribe over there, do have a look at the LinkedIn page, and we will be announcing the winner. And the winner will be getting one winner will be there, and they will be getting the Azure voucher, and you can give DP-100 certification with that voucher. So I think, Mamta, they are still attempting the quiz, and we can give them at least, let's say, 1 hour for solving the quiz, and one of the lucky winner will be the one to whom we will announce the result on the LinkedIn page within 1 hour, or after post 1 hour. So everyone who's you have till 1 hour, just put your answers there, and if the one who's answering who have the most correct answers, we'll announce the winner on the LinkedIn page.
Make a post in the LinkedIn page, and please share your correct details, because it was difficult last time to find the correct person and tag it on LinkedIn. So if you can share the correct details, give the full name, that would be really helpful. And you would be receiving Azure exam voucher for free, and you can get certified in any of the exams of Azure, as any certification you can get through. So that would be really good if you share the correct details and answer the questions. As Shivam said, we would be providing you next 1 hour. So it's 10:36, and we would be closing the window by 11:36. And maybe by tomorrow morning, I think it would be pretty late for us, Shivam. Let's not commit today night. Let's decide and announce the winner tomorrow in the morning on our portal.
Sure. That's fine.
Yeah. Fine, then I think we are doing good. And thanks, guys. Thanks for joining us. And stay tuned, and do join us for the upcoming webinars. And in case you are interested in any of the training programs, you can drop us an email as well. fine, Shivam. I think we can close the session now.
Sure. Thanks, everyone. Thanks for joining. And stay tuned. Just subscribe to the LinkedIn page so you can be you get the notification for our upcoming webinars. And we'll see you soon.
Thanks a lot. Take care, guys. Stay safe. Bye. Thanks, Kopal. Thanks, Ketan. Thanks, Shivam. Good day.
Thank you so much.
Bye.